Okay, this problem says that you step onto a hot beach with your bare feet. A nerve impulse generated in your foot travels through your nervous system at an average speed of 110 meters per second. How much time does it take for the impulse, which travels a distance of 1.8 meters, to reach your brain? Okay, well, first thing I would do is draw a sketch of what's going on. One-dimensional motion, so we can draw kind of a number line thing. I can say x0 equals 0, t0 equals 0. V is in this direction, both initially. I can say v0 is in that direction, but all throughout the trip. Here, x, we can call it x1, equals 1.8 meters. T1, we don't know what that is. So if I write over here in my knowns column, I can write V, well, you can write V1 as well. V0 equals V1 equals 110 meters per second. The delta x is going to equal 1.8 meters, or written another way, you can say x0 equals 0 and x1 equals 1.8 meters. What we're looking for is delta t, and if we set t0 equal to 0, then delta t is just equal to t, or t1, excuse me. I label it t1 here. Well, in this situation, we could start with, the definition of average velocity is delta x over delta t, which would work here because the velocity is constant. So v then equals the instantaneous velocity equals the average velocity. So that's probably the simplest way to do it. So the average velocity then is equal to x minus x0, x1 minus x0, t1 minus t0. This is equal to 0. We set both of these equal to 0. It's arbitrary. We don't have to set those equal to 0, but it makes sense. So the average velocity is now just x1 over t1, and t1 is then x1 over average velocity, or I can also write over just velocity because it's the same throughout. So now that I've solved for my expression for time, I can plug in the numbers. 1.8 meters is x1, and 110 meters per second is the velocity. If I divide that out, I get 1.60 times 10 to the negative 2 seconds. The units work because meters over meters per second. That's the same as saying meters over 1 over meters per second. And when you divide fractions, meters over 1, you flip the fraction in the denominator over seconds per meter. Meters cancel, and you're left with seconds. And we'll put a box around the answer.